Differentiation in a mathematics is a process of finding the derivatives or rate of change of a function. In contrast to the abstract nature of the theory behind it, the practical technique of differentiation can be carried out by purely algebra manipulation, using three basic derivatives, four rules of operation, and a knowledge of how to manipulate function. The differentiation is all about finding the rate of change of one quantity compared to another. We need differentiation when the rate of change is not constant.
Introduction to stationary point. Differentiation is widely used in science and engineering field. It can help us solve many types of real-world problems. Some applications of differentiation include targets and normal Newton methods, rate of change and finding maximum and minimum points, and curve sketching. We will discuss about finding stationary points by using differentiation and also sketch the graph. Let's begin.
How to find stationary point? Question give a curve has an equation of y equal to 3 square root minus 3x square minus x plus 3. First Roman, work out the coordinate of the stationary point. Second Roman, sketch the curve of y equal to x square root minus 3x square minus x plus 3. So I want to explain stationary point. The question is y equal to x square root minus 3x square minus x plus 3. The answer is dy over dx equal to 3x square minus 6x minus 1. dy over dx equal to 0. The stationary point 3x square minus 6x minus 1 equal to 0. Okay, how to get the answer for 3x square minus 6x minus 1 equal to 0? You must use calculate. You press the mode 1, 2, 3, and then you press the 1, you press the mode, and you press the 2 for degree 2. Okay, so you can calculate and get the answer. Okay, how to get the answer y? You must refer the first question, y equal to x square root minus 3x square minus x plus 3. You must change x to x1 is 2.2. You must write 2.2. So y equal x, you must change 2.2. You open bracket and you write 2.2. You close bracket and square root minus 3 open bracket 2.2 and close bracket square minus open bracket 2.2 close bracket plus 3, and you get the answer is y1 is negative 3.1 and y. Okay, for the get y2, you must follow the step y1. Okay, you can get 3.3. Okay, the answer is x1 and y1 is 2.2 and negative 3.1, and the answer is x2 and y2 is negative 0.2 and 3.3.
Thank you, Shawan, and I will take it from here. So, I will show you guys how to determining the type of the stationary point. First of all you need to do is just take the first differentiate here, which is dy over dx equals to 3x power of 2 negative 6x negative 1 to become the second differentiate, which is d2y over dx2 equals to 6x minus 6. So for the second step is, all you guys need to do is just take x1, which is 2.2, and change the x to 2.2, that you will got 6 open square root 2.2 and close square root minus 6 and put them to the calculator and you will got 7.2 which is bigger than 0. And for the x2, all you need to do just take this x2 equals to negative 0.2 and change it just like the x1. So 6 open square root negative 0.2 close square root and negative 6, put into the calculator and you will got negative 7.2 which is smaller than 0. So for the minimum point is 2.2 and negative 3.1. For the maximum point is negative 0.2 and 3.3. How do I get these two? It's very simple. So all you need to do just take x1 is 2.2 and y1 is negative 1, negative 3.1. So this will become our minimum point. So for the maximum point, take the x2 which is negative 0.2 and y2 equals to 3.3. These two will become our maximum point.
So, I will show you guys how to sketch the curve of y equals to x power of 3, negative 3x power of 2, and negative x plus 3. So, first of all you need to do is just change this question to A, B, C, and D. How you're going to do that? Just take a calculator and find the button mode and click it 3 times. 1, 2, 3. You will see a EQN and click number 1. And go to the left, click number 3. You will have A, B, C, and D. So, for the next step, just change this question to A, B, C, and D just like this. X power of 3 will become A1 and negative 3x power of 2 will become negative 3 and negative x will become C1, negative C1, negative 1 and 3 will become D equals to 3 and click the button equals and you will have x1 is 3, x2 is 1, x3 is 1, negative 1. So, for the second step, you need to find at a y-axis x equals to 0. So just change this question, x is 0. So every calculation here that have x will become 0 and but this 3 is just stay 3 because there are no x beside the 3. So there you go, you will have y equals to 3. You got all this information to do the graph. So this is the graph that I made. So A is our minimum point and B is our maximum point. This I get from Shawal that showed the calculation before. So I only just plot the A and B into the graph. A is 2.2 is and negative 3.1 here, right here. And B is negative 0.2 and 3.3 right here. So C is 3.30 right here, C 30. And D is 10 right here, 10. And E is negative 10 here, negative 10. And F is 0.3. Here you go, 0.3. And after you're done plotting the number, just make it and then make a line and connect every dot that you plot in the graph and you will have this S upside down. There you go. You will have your graph. That's all.
Next on to the introduction of rate of change. One of the more important applications of derivatives in real problem is to calculate rates of change. Differentiation allows us to find rates of change. For example, it allows us to find the rate of change of area with respect to time. Now, we will try to solve a simple question to get you a better understanding on this topic.
How to find rate of change? Question. The radius of a circle is increasing at the rate of 2 cm per second. Find the rate of change of the area for the circle at the instant when the radius is 5 cm, given A equal to pi r square.
To get the answer, which is step 1, let's all take out all the information given, which is dr per dt from the radius is increasing at the rate of 2 cm per second. That is what we get from dr per dt. Because it's increasing, so it will be positive. Next, find the rate of change of the area. So this will be our dA per dt, and this is what we must find. So we just gonna write it down like dA per dt equals to what we want. And then the next information is radius is equal to 5 cm. So we just gonna write it down as r equals to 5 cm, and the area that give us is a equal to pi r square. Step 2, let's differentiate area from what they given. So as we differentiate dA per dr, we will get only pi r left. Next, the next step is insert all the information that we have now. From what the question 1 is dA per dt, so what we the solution is dA per dr times to dr per dt equals to dA per dr, which we got is pi r, and dr per dt is 2 cm per second. And then we insert all the information. R is equal 5 cm, and after all we calculated, and the final answer will be 31.42 cm square per second.
So, from my side opinion about application in stationary point kejuaraan awam is how engineering going to build a roller coaster track. So, this is because how the engineering going to calculate the every point in highest and the lowest position. So, I think this is for to guarantee the safety of the user. So every bar here every bar on the roller coaster track have its own function to stabilize the roller coaster track here. So I think the stationary point is very suitable how they're going to calculate the every highest and the lowest point to guarantee the safety for the user. So I think that's all.
Example application of differentiation in real life to check a variation height to determine speed or distance traveled, such as a mile per hour, kilometer per hour. Derivatives are used to produce many equations in physics and mathematics. In engineering studies, like to find the maximum point and minimum point in order to build something like a roller coaster.
What is the average rate of change used for? Essentially, the average rate of change or slope is extremely useful to measure the rate at which something changes over a specific period of time. Consider the following application where the average rate of change is a useful way to measure change or time. In engineering, slope is a mathematical concept that is extremely important in the construction industry. For instance, new building plans require accurate measurement and calculation about a location, topography, and how the change in elevation can affect the construction of structure. The data that give engineer and architect the information they need to develop structural plans for construction project. The plans that engineer and architect develop take into account land scope and other features to ensure valuable structure like building, roadway, bridge, and other infrastructure.
What is the use of differentiation in civil engineering? Applications of differentiation are almost everywhere, from the displacement of a beam to complex shell and membrane displacement or fluid-induced non-stable vibration. Any work revolves around modeling structures, fluids, pollutants, and more can be modeled using differentiation equations. We will likely have to use the set differential equations in an approximate frameworks to approximately figure out a solution to a problem we are facing.